Today, we are talking about the most terrifying tornado variations. What if I told you there's a tornado so massive it doesn't even look like it's moving? Or one that's completely invisible until the moment it starts destroying things? And that's not even close to the most terrifying variation ever documented. The night tornado. Picture this. You're staring into pitch black darkness, knowing something massive is moving toward you. Then lightning strikes, and for half a second you see it. A wall of destruction. Then it's gone. Complete darkness again. Night tornadoes aren't meteorologically different from daytime tornadoes. Same rotating supercells, same wind shear, same atmospheric ingredients. The terror is purely sensory. After dark, there's no sunlight to reveal the condensation funnel, no contrast against the sky, no visual warning system your brain can process. Lightning becomes your only source of information. Brief, irregular flashes that show you snapshots of a tornado that might be a mile away or right on top of you. In that fraction of a second, you're trying to determine size, direction, speed, and whether you need to run. The human brain isn't built to process threats this way. We rely on continuous visual input to assess danger and make decisions. When that input becomes fragmented, our ability to judge distance and speed breaks down completely. What looked a mile away in one flash might be 200 yards closer in the next. And unlike rare variations we'll cover, this happens constantly. Tornadoes don't stop forming just because the sun goes down. Nocturnal tornadoes account for a disproportionate number of fatalities precisely because of the visibility issue. People are asleep, warnings go unheard, and even those who are awake can't see the threat approaching. The rain-wrapped tornado. You're looking at heavy rain, thick gray curtains of precipitation moving toward you. Except hidden inside that rain is a tornado, and you won't see it until debris starts hitting your house. Rain-wrapped tornadoes occur when a tornado becomes completely embedded within the precipitation core of its parent storm. Heavy rain surrounds the vortex on all sides, creating an impenetrable visual barrier. The tornado could be EF3 intensity with 150+ miles per hour winds, and from any angle all you see is rain. Everything looks like a typical severe thunderstorm. You see rain, hear thunder, maybe notice stronger winds. Your brain categorizes it as severe weather, but not immediate life-threatening emergency. There's no visual trigger, no funnel, no debris cloud to override your assumption that this is just heavy rain. By the time the sound of the wind becomes loud enough to distinguish from rain noise, the tornado might already be on top of you. And at that point, you've got seconds, not minutes, to take shelter. Even experienced storm chasers struggle with these. You can be positioned perfectly, staring directly at the storm, and see nothing but rain. Radar shows violent rotation, warnings are being issued, but visually, zero confirmation until debris starts flying. The fire tornado. Forget everything you know about tornado formation. Forget thunderstorms, moisture, atmospheric instability, cold fronts. Fire tornadoes need none of that. Just heat, wind, and fuel. When extreme wildfires generate intense heat, with temperatures exceeding 2,000 degrees Fahrenheit, the superheated air rises rapidly in powerful updrafts. Surrounding winds and terrain introduce rotation into that rising column. When the rotation tightens, a vortex forms, pulling flame, burning debris, and ash into a spinning column of fire that can reach over 100 miles per hour. These aren't small fire whirls. We're talking about tornadic vortices with EF scale intensity. They melt paint off cars, warp metal, and lift vehicles and hurl them hundreds of feet. The sound is described as a mechanical roar like a jet engine screaming. You can't see them coming on Doppler radar. Weather radar looks for precipitation and measures wind speeds within storm clouds. Fire tornadoes have neither. The Carr Fire in California generated the first fire tornado ever to receive an EF rating, EF3 intensity. It killed a firefighter and a civilian. It destroyed over 1,000 structures. Firefighters describe them as the most terrifying thing they've encountered. You're already fighting a wildfire, extreme heat, zero visibility from smoke, unpredictable behavior. Then the fire itself starts spinning, generating winds strong enough to flip fire trucks, and you realize you're not just fighting fire anymore. The wedge tornado. Wedge tornadoes don't look like funnels at all. They're so wide they appear as massive walls of churning cloud connected to the ground, often wider than they are tall. Some even exceed a mile in width. Entire towns can fit within the damage path. But here's the deadly illusion. They appear to move in slow motion. Wedge tornadoes move at the same forward speed as traditional tornadoes, typically 30 to 50 miles per hour. Because they're so massive, your brain can't process the movement properly. They look like they're barely creeping forward, almost stationary. By the time you realize the wedge is far closer than it was 2 minutes ago, it's too late to evacuate. You've wasted critical escape time standing there watching, convinced you had more time because it looked so slow. The waterspout tornado. Coastal communities see a waterspout forming offshore and think, it's over the ocean, we're safe. That assumption kills people. There are two types of waterspouts. Fair weather waterspouts are generally weak and short-lived, but tornadic waterspouts are real tornadoes generated by supercell thunderstorms that happen to form over water. Same rotating mesocyclone, same violent updraft, and the same destructive potential. When a tornadic waterspout crosses a coastline, it doesn't weaken, it often intensifies. Over water, the smooth surface reduces friction, but when that vortex moves over land, over beaches, buildings, trees, uneven terrain, the increased surface friction can tighten the rotation, accelerating wind speeds. The waterspout that looked peaceful over the ocean is now a tornado moving inland at 40 miles per hour and getting stronger. Tornadic waterspouts can sustain themselves for miles after landfall, crossing beaches and moving through coastal towns. And because they don't always produce classic radar signatures, warnings can be delayed or absent entirely. By the time people realize it's not just a waterspout, it's already causing damage. The invisible tornado. There's no funnel, no condensation cloud, no visible tornado. Just destruction appearing out of nowhere. Invisible tornadoes form when atmospheric humidity is too low for moisture to condense into a visible funnel, or when the vortex exists primarily at ground level, without extending visibly upward into the cloud base. The rotation is absolutely real, but there's nothing for your eyes to lock onto. Think about what a tornado actually is. It's a rapidly rotating column of air. The visible funnel we associate with tornadoes is just water vapor condensing inside that rotating column. But if the air is too dry, the rotation still exists. You just can't see it. Storm spotters have reported experiences that sound almost supernatural. Objects start flying, structures start coming apart, and there's nothing visible causing it. Doppler radar detects these perfectly. It's measuring wind speeds and rotation directly, not moisture. But if you're depending on your eyes, the tornado is already hitting you before you realize a tornado exists. The rope tornado. Picture a ribbon hanging from the cloud, swaying gracefully like it's dancing in the wind, beautiful in its fluid motion. Then it touches down and rips a barn apart in under 5 seconds. Rope tornadoes look fragile. They often form during a tornado's dissipating phase as the vortex contracts. The visual appearance screams weak to anyone watching. But thin doesn't mean weak. It means concentrated. When rotational energy compresses into a narrow column, sometimes only 50 to 100 feet wide, wind speeds can spike dramatically. Conservation of angular momentum. As the radius decreases, rotational velocity increases. A rope tornado can generate EF2 or EF3 winds in an extremely focused area. Storm chasers describe them as deceptively beautiful, mesmerizing, photogenic, almost hypnotic. It's easy to get captivated by the visual beauty and forget you're watching something capable of extreme violence. The anticyclonic tornado. Every tornado in the northern hemisphere spins counterclockwise. This is fundamental meteorology. Radar systems are calibrated for it. Storm spotters are trained to watch for it. It's the rule. Then, very rarely, a tornado spins clockwise, completely backward, and shatters every pattern we use to detect them. Anticyclonic tornadoes violate the dominant rotation direction. They don't form beneath the main updraft like typical tornadoes. Instead, they develop along the outer edges of supercells, where opposing wind boundaries collide and create reverse circulation. Most stay weak, but occasionally, when a supercell splits, the left-moving storm can develop a dominant anticyclonic mesocyclone. Storm spotters trained to identify counterclockwise rotation can watch an anticyclonic tornado approach without recognizing it. Your brain sees motion that looks wrong somehow. You might hesitate, doubt what you're seeing, spend critical seconds trying to reconcile the visual with your expectations. Visually, you cannot tell the difference from a still image. The only distinction is rotational direction, and unless you're close enough to observe individual debris movement, you'll never know which way it's spinning. The multi-vortex tornado. Now imagine looking at a tornado and seeing multiple smaller tornadoes rotating inside it. Distinct funnels weaving around each other in chaotic, unpredictable patterns. Multi-vortex tornadoes contain 2 or more suction vortices that orbit within the main circulation. Each suction vortex has its own intense rotation layered on top of the parent tornado's rotation, creating localized wind speeds far higher than the broader storm. This creates damage patterns that look random. One house is completely erased, while the house next door is nearly untouched. The spacing between suction vortices can be 50 to even several hundred feet. As the tornado moves, the vortices rotate around the center, creating multiple damage tracks that weave in and out. Suction vortices appear and disappear rapidly. The parent tornado might exist for 30 minutes, but individual suction vortices might last only 30 seconds before dissipating and being replaced by new ones. Radar might show one circulation, but on the ground, there are 3, 4, 5 distinct funnels. For anyone sheltering, this is uniquely dangerous. You might survive the initial impact, only to have a suction vortex pass overhead seconds later with catastrophic force. Your shelter might be rated for EF3 winds, but a suction vortex with EF5 winds can exceed those ratings.